Let's continue with this example with the following question. If Patty needed to get in the top 10% to get an A, what score would she need to get on the exam? Now this is fundamentally different than the norm dist function because in this problem we're actually given a probability and we want to calculate a value, where in the norm dist function previously we're given a value and we want to calculate a probability. So we use a different function, and we can still use the approximation method. We can still use the tables that we'll discuss. But in this case, we would start from a probability and calculate a value, so we would use a norm inverse function. So going back to the example that we have previously, in this example, we're going to start from a probability from negative infinity to x. We still need to know the mean or the center of the distribution and the standard deviation of the distribution. But the output for the norm inverse function will actually be a value. So if Patty needs to be in the top 10%, that means the probability from negative infinity to x would be the lower 90%, or 0.9. The mean, as we know previously, is 50, and the standard deviation is 12.5. So the function we're going to use this time is norm inverse. The inputs are the following. First is the probability, and that, remember, is always, always, always from negative infinity to that value. So in the problem it says she wants to be in the top 10%. Well, to be in the top 10%, we have to input the bottom or the left-hand side lower than that value, which is 90%. The next input is the mean or the standard is the mean or the center of the distribution, and then comma followed by the standard deviation. There is no continuous function like we had in the norm dist because it is always assumed to be a continuous distribution, not a discrete distribution. So when we hit enter, we find that she needs to score at least a 66 or higher to be in the top 10% of her class.